Okay, well, welcome everybody to yet another edition of Drunk Agile. As always, I am Daniel Vacanti, and with me is
Prateek
Singh. As is customary, we start off by talking about what we will be drinking tonight and debating about whether we should pour first or pour after. But we decided this time to not pour first. I don't know, Prateek, do you want to go and talk about what you're drinking tonight?
Sure. I picked a GlenDronach cask strength. This is batch 7. It's sherry cask base, Oloroso, and Pedro Jimenez casks, and no chill filtered, 57.9%.
Yeah.
So, a bit of a sherry bomb.
Yep, somebody's a bit of a trend follower because I think I went with the GlenDronach last week, if memory serves. So I went with a Prateek-sized bottle here. This is a Glen Kinchy. This is a bottle that I once again, keeping in that theme, a bottle I bottled myself at the Glen Kinchy distillery. It's a 2009, so I think it was 9 years old at the time. 55.2% bourbon cask, as you can probably tell by the color. So let's pour that.
I think folks will eventually notice the sherry and bourbon cask trend here.
I don't know. I might even. What do you guys think? Should we just kill it off? I think we're going to kill it for tonight. For what we're going to be talking tonight, we're going to need to kill it.
Yeah, that's a good one for tonight.
Yeah. Well, so Prateek, would you like to introduce our topic for tonight, or shall I? Or no, I think you should.
Let me introduce, and because I have a feeling you'll do the lion's share of the talking here.
Cheers.
Cheers.
Slanjava.
That is good.
I picked a good one. Wow, this is really good.
So today, before we get to today, let's talk about last time. Last time we covered Monte Carlo and how we go about doing Monte Carlo when we have Teams throughput available and we know how many stories, work items, whatever you want to call them, need to get done, or we know which date we want to march to. That's what we talked about last time. This time, since we told you last time what to do, this time we want to talk about what not to do. What are the things that we commonly see being done with Monte Carlo, with the modeling behind Monte Carlo, and some pitfalls you might want to avoid when you go to make a transition towards using something like Monte Carlo.
Right. Okay, so
Go for it.
Okay, so I think the first one's probably on both of our minds is this concept of curve fitting. Those of you out there, maybe you've heard about curve fitting, maybe you haven't. But if you've done any research on Monte Carlo, a lot of times Monte Carlo methods will suggest that you sample from a very specific probability distribution, right? You try to understand what the distribution of your data is, and you sample from that distribution. So a lot of people will take that one step further and say, okay, well, if we have all this historical data, what we want to do is we want to fit that historical data to some specific curve, some specific probability distribution. So if we have a normal distribution, or if we have a Weibull or whatever the hell you call it distribution, then we can use that probability distribution to do our sampling for us. In terms of running our simulation. And there are all kinds of problems with that that actually really mostly derive from just one specific problem. So I don't know if you want to talk about the one problem that you think, or maybe I can go with the one problem that I think.
I can say what problem that I think, which is is that it's a very big assumption that we are making that this distribution actually represents a real data. First of all, and not to get too mathy on this, our real data is discrete, distributions are continuous, but in any...
Although you can have discrete distributions, but let's not go there.
Exactly. But most of the distributions that people do curve fitting to, at least curves, are continuous. And it's not necessarily true. This is the exact same reason why we shy away from averages and standard deviations, because those usually assume a normal distribution.
Yeah.
And we can't make that assumption on top of our data, even if we find some very nice fitting distributions.
I think so. We talked about. We've probably talked about the flaw of averages every single time. I don't know.
Yes.
So why stop now?
Yeah.
But I think it's Dr. Sam Savage in the flaw of averages where he talks about, the fancy curves or fancy probability distributions are. And is it he that says the steam engine era hacks? I know, is that from
would
Sam
like
Savage?
to say yes.
Yeah, we'll have to go look that up.
Yeah.
One time when we haven't been drinking, we'll go look up that reference. But yeah, the fancy calculus around these probability distributions were hacks essentially, because the probability distributions that we see the data that we see in the real world is not generated by some distribution, right? Your data will never fit a given distribution. These distributions are just mathematical, statistical hacks, just to make the math easy, because way back then we didn't have computers. We didn't have these things to do all these calculations for us. So they had to do it by hand. So they came up with these hacks to your data. So there's no, probability distribution out there that are, normal distribution that's generating all the data for a normal distribution. It just doesn't happen. And so that's the most thing. And as you were saying, it doesn't take much to invalidate the assumptions around whatever curve that you choose. And then once those assumptions are invalidated, which will happen very quickly, then of course the model becomes invalid and your results become invalid.
And the other part of what you were saying, which is we didn't have computers to generate to sample or do that sampling really fast. Even more, we didn't used to have all that data stored anywhere either. We have a plethora of data available. Even when you think you don't have enough data available, we have so much data available that we don't need to resort to the hack of a distribution to sample from.
Yeah, we talk about that a lot. Generally speaking, a lot of people talk, are they worried about, we don't have enough data. You need so much data to do Monte Carlo. So this is maybe another kind of off on another thing to watch out for is, number one, you really don't need that much data to run a Monte Carlo simulation. You'd be surprised at how little data that you need. But number two, the problem, generally speaking, as you were saying, the problem isn't that you have too little data. Usually the problem is you have way too much data. And now we need to make a determination about what data is relevant for our simulation. Because of course, whatever data we feed in is going to be the largest influencer of what data comes out. So I don't know if you want to say anything more about that, but
I don't know how much time we want to spend on curve fitting, but that's yeah.
About this much time.
About that much time.
About that much time. That's how much I want to spend.
But it's as you said earlier, most literature, at least most prevalent literature, goes towards, hey, let's use some sort of a curve to sample from, and much of that literature descends from older thinking, from or older techniques when we did not have the availability of all this data. So I think I'm hoping we've put enough of a bow on that to say, you have the data available, use the data itself, don't make assumptions on top of the data, use the raw data that you have.
Yep.
The closer you are to it, the fewer assumptions you have made, essentially.
Yep. Your system generated your data. A probability distribution did not generate your data. So if it's your system, your process that generated the data, by all means use that data. Prateek and I talked to a gentleman by the name of Dr. Wheeler. That was about 2 months ago.
Yeah.
And he's very, very, very big on this. Is the second that you start talking about either fitting your data to a curve or transforming your data to make it even look better, a lot of people will talk about, well, yeah, first you need to transform your data to be normally distributed, and then you'll fit it to a normal distribution, which is like, I don't know, that's just beyond stupid. But the second you start getting into that stuff, you lose so much fidelity in terms of what you're trying to do. Don't even bother You have your data. We have modern computers, these fancy little things that will do tremendous things for us. You have your data, use your data. So
Yeah.
I don't know, that was much faster than this.
I was just going to do a shout out to Dr. Wheeler. I mean, it was a real treat talking to him when we did. And if you guys are really interested in this stuff, please go out and read his stuff. Read the stuff he's written. It's very, very informative. Right there.
Dr. Donald Wheeler. I mean, he's not, and we should be clear, he's not specifically talking about Monte Carlo per se, but he is talking about modern statistical methods that we should be applying, and they have very, very little to do with those steam engine era hacks. So, okay, so that's number one. Number one of what not to do with Monte Carlo. The second one I think that was kind of on our list is this idea of split rate. Well, so obviously, Prateek, the more information that we have that we can feed into our model, like we need to know, just because our backlog says 100 stories, we know that those stories are going to split into multiple stories. So we need to look at historical split rate, or we need to look at historical arrival rate of unexpected or unplanned work or whatever. That's all information that we need to have to feed into our model, right?
Yeah, right. In fact, let's attack those separately.
Okay.
Split rate and arrival rate separately.
Fair enough. Okay. Yeah.
Let's limit our whip on this thing. Let's take split rate. I don't even know where to start with split rate.
I do.
Go for it, because I'm going to need to get through this in order to start with split rate.
Let me start with kind of an obvious thing. So, I mean, when you start, I think when you start thinking about split rate and when you start adding that to your Monte Carlo simulation, you're very quickly starting to answer, to me, the wrong question, right? To me, this is really not what Monte Carlo is meant to be answering. What a simulation, at least the way that we talk about it, what the simulation, the question that the simulation is trying to answer is either, hey, how many things can we get done by a specific date? Or given a certain number of items, how long, what date is it going to be before we can get those number of items done? Neither one of those things necessarily need to or should speak to this idea of split rate. And the reason I say that, so let's take the second one first. And I'm just going to talk for a while so you just enjoy your drink.
I'm probably going to go through two of these before.
Yeah. So let's take it where we have a certain number of items. Let's say we have 100 items and we're trying to decide, well, okay, these 100 items, what date is that going to be done? The way to think about that, you shouldn't be thinking about it in terms of, oh, I've got these 100 items in my backlog. I'm going to get all 100 of these things done by this date. That's not what the simulation is telling you. What the simulation is telling you is, if you have a budget of 100 items, right? You have a budget of 100 items. They will get done by this date. Now you can spend that 100 however you want. You can split the stuff in your backlog. You can have new stuff arrive, whatever. I know you don't want to talk about any of that, but though that 100 is your budget, and you need to kind of, in a just-in-time and more of a continuous fashion, decide the right way that you are going to spend that budget. And for me, the problem with split rate specifically is, to me, when you do story splitting, and we talk a lot about story splitting, I think story splitting is the secret sauce to make agile, lean, flow, everything work. If you don't have a good way to split the stuff that you're working on, you're kind of screwed. But to me, story splitting is all about finding out the stuff that you shouldn't do. It's not about finding the stuff you should do. It's about finding the stuff you should not do. So just because we have this story and it splits into 4 stories, that doesn't mean we're going to work on, I know this is a hot button for you and I'm stealing your thunder, but that doesn't mean we're going to work on all 4 stories. What that does mean is, hey, this thing was bigger than we thought. We can probably scope it down to this 1 story. Those other 3, let's throw those away. Maybe we put them back on the backlog. Maybe we never get to them. I don't know, but I like I said, I stole all your thunder, so you jump in.
Yeah, that's fine. Because I think there's one thing at least that you didn't mention, which I get to mention.
Okay. Cool.
Because for me, split rate has 2 big problems. There are other problems, but 2 big problems. One is the one that you were already talking about, which is we don't want to hide prioritization decisions behind split rate. We want to be explicit about prioritization decisions.
Okay, but say, okay, there's a lot in that statement.
Yeah.
Can you unpack that a little bit? How am I hiding prioritization behind a split rate? How am I doing that?
Let's say that I'm saying that my split rate is 2. Every story splits into 2. I know that happens historically. Rather than saying that, and I have through Monte Carlo determined that I am comfortable planning for 100 stories. I have an 80% confidence, which is the level of risk I want to take, that I can get 100 things done. At that point, saying that I'm going to plan for 50 stories because I'm going to split these is saying that these 50 and their splits are the highest priorities, as opposed to saying that I'm going to plan for 100 items, and when they split, I'm going to make the prioritization decision of, is the new split more important to keep here rather than throw out and bring something else in, or just expose that problem that we had initially, of not having made the right priorities.
That's hugely important. I hope people are understanding what you're saying, because that is hugely important. You're right. We're making.
It doesn't usually happen.
I know. just wait. We got some doozies coming up, right? Next couple podcasts we're going to do, or whatever these are.
Yeah.
Okay, but anyway, keep going. But if you didn't follow what Prateek said, go back and rewind, because I know you're listening to this at 5 times speed or whatever. Go back and listen to hiding prioritization decisions behind split rate, because that's key. Okay, sorry, go ahead.
Yeah, so that's problem number 1 for me, which is hiding prioritization decisions behind split rate. And problem 2 is the same problem we had with the curve fitting, which is you're adding another assumption into the equation, that the rate at which we have been splitting in the past is the rate at which we'll be splitting in the future. That the work that's coming up is of similar complexity, if you want to use that word, as the one before. We've already made an assumption when we've started using Monte Carlo to say, we'll be able to keep our throughput stable. We've made that assumption through operating a stable system, which is for another day. We're supposed to drink every time we say another day. But through operating a stable system, we'll be able to create stable throughput, and hence come to a point where Monte Carlo or past can represent the future. That's assumption 1 that we have made. Now we're adding an assumption of we'll also be splitting things at the same rate.
Yeah. Actually, you know what? It's fast. I hadn't thought about this before, but you just made me think. Split rate is classic law of averages thinking, right? Because what we're assuming is
at the time.
That split rate the split rate that you calculated is probably an average, right? Mm-hmm. Not probably. I'm sure it is.
Most likely.
I'm sure it is your average. And so now we're building yet another, to your point, now we're building another assumption into a Monte Carlo simulation that's based on an average, which brings us into flaw of averages, territory. So
maybe it should be every time we mention flaw of averages, we take a drink.
Yeah. It really is. I mean, everything does come. We should do a whole, again, take a drink. We should do a whole podcast. I don't know if we've talked about this before, but a whole podcast about how numbers are being reported for this COVID-19.
Yeah, for COVID. Yep, absolutely.
For those of you
we talked about that a couple of times ago. Yeah.
If you're in the future, we're still kind of in the midst of this pandemic that is this COVID-19, and just the math around the whole thing, how numbers are being reported is just so bad. But yes, we're throwing an assumption, on top of an assumption that's probably going to be false and invalid, potentially as much, if not more than 50% of the time.
Yeah, and what's interesting with that is we try to move away from the flaw of averages by ditching our average single line forecasting, and we're kind of bringing that element back in. Now, again, to me, the math is important, but it's probably still not as important as that point number 1 of, we don't want to hide the prioritization decisions. We want to make those explicit.
Right.
And to me, the point number 1 overrides point number 2, but point number 2 is important as well.
We should talk about that maybe just for a little bit, and because something else we're talking about hiding that prioritization decision. if we have 10 stories that we're working on and we're working priority one, and that priority one gets split into 4 stories, like I was talking before, now we have, as everybody probably figured out, we have a prioritization decision that we have to make. That number one priority gets split into 4 stories. And as I mentioned before, splitting stories is really about finding about what you shouldn't be doing. So now we need to take a look at those 4 stories. Are those 4 stories, are they all number ones? Which I think is what happens in probably most contexts, right? Yeah. You split it, and then of course, well, everything's a number one. Well, no, really. That's not true, because our Monte Carlo has told us we have a budget of these number of stories. If you want to spend that $100, if you want to spend that 100-story budget on those 4, by all means do it. But then that means that there's another 4 that you're probably not going to get. Right. So
yeah, it's I mean, to just I think that the scale of the numbers makes it really interesting. Like if you have a budget of 10 stories and you're gonna say, I'm gonna plan for only 2 because my split rate is 5. At that point, when both of them split and they become 10 eventually, let's say magically you are right and they become 10. At that point, not all 10 of them are as important or more important than that priority number 3 that you threw out right at the beginning, because you assume that, because I have a split rate of 5, I can only think about these first 2 things.
Right. So, okay, we've probably beaten that one. So do not. We should never really say with 100% certainty, do not do something. But generally speaking, I would argue split rate, incorporating split rate into your Monte Carlo simulations is an anti-pattern for all the reasons that we just talked about.
I mean, there might be some information hidden in there that we haven't exposed or we haven't encountered yet. There might be some validity to say, let's look at a regular forecast and then let's look at a split rate forecast and see what might happen if these things happen. I don't know. I have never tried to explore that.
Yeah, but remember, I mean, I keep coming back to, it's all about risk management. It's all about risk management. And so if you've run a Monte Carlo simulation not using split rate, and it turns out that your stories are bigger than what you thought, and the requirements are ballooning or whatever, well, this is where continuous forecasting, in my opinion anyway, continuous forecasting comes and saves the day. Because remember, we're not just running one forecast. We're running multiple. We're running them hopefully continuously as we get that new information. We don't maybe necessarily need that split rate. That split rate could be kind of built into the model itself. So, okay, that's enough. Sorry, go ahead.
We didn't get enough into continuous forecasting last time, so we might have to. We might have to talk about that if we have time today. We'll talk about that today.
So many things to talk about. Of course, 10 weeks from now, we're going to be like, oh wait, what do we talk about now?
Yeah, exactly.
Okay, so this arrival rate thing, you kind of said, well, let's talk about the arrival rate thing later. Well, what about
you said split your stories, so I split that out.
Fair enough. Touche. He's getting me back for the Prateek joke.
Yeah.
So what Prateek? What about unplanned work? What about this new stuff that just shows up? What about all of this? Don't we need to know about that in terms of incorporating that into our model?
I said let's split it up, but now I'm going to say see previous section.
Okay, I'm not one to say I told you so. I'm not one to say I told you so, but they're kind of the same.
But it's while there are 2 different things that you're doing to your forecast, they're hiding at least those 2 same problems. Problem number 1, that you're making prioritization decisions way too early by saying that, oh, this stuff is going to come in, so I can't make that other prioritization decision. And then the second problem, obviously, is you're adding another assumption to your forecast. And as you mentioned earlier, it could again be pulling us back into the flaw of averages thing. So the same 2 things that plagued us with the split rate forecasting, I believe, are still valid for arrival rate forecasting.
Yeah, absolutely. It's really going to be it's going to come down, when we talk about what not to do, it's really going to come down to trying to figure out what's the simplest model that we can use that is going to give us an as accurate an answer as possible with as little effort as possible.
Mm-hmm.
And the second that we start piling assumptions on top of assumptions on top of assumptions, that's when we're going to get in trouble. And it's kind of like traditional project planning, right? I mean, we're going to spend all of our time updating the plan, updating the model, updating. I was like, oh wait, there's this other little bit of complexity that we need to add in, and that'll give us, at some point, where we tweak the model beyond all usability. So generally speaking, if we can put a blanket statement around it, don't do that. If you're adding complexity to your model, you're probably doing yourself a disservice rather than helping your cause at all.
Yeah, and going back to the theme of what not to do, at least these three things that we've talked about, curve fitting, split rate, and arrival rate, the thing that they're trying to compensate for, in my opinion, is that we are not running our forecasts often enough.
Mm-hmm.
And this is where I'm going to drive this into continuous forecasting. If you are forecasting as soon as you get new information, if you're reforecasting as soon as you get new information, you wouldn't need to do those things, or you would have to rely on those things a lot less. If you're not doing that, and if you're doing your forecast at the beginning of the release slash project right there, and then going, this is the plan, then you will probably be attracted more towards those other assumptions that muddy your forecast.
Yeah, and if you're familiar with Monte Carlo simulation and you are doing Monte Carlo simulation, then you have absolutely, in my opinion, again, you have absolutely no excuse to not do continuous forecasting, because you understand what we're trying to do. You understand how model works. You understand how Monte Carlo simulation works. You see how easy it is. You see we have these fancy things called computers that really probably usually all you have to do is push a button and it turns out a simulation. So you have really no excuse if you're heading down the Monte Carlo path to not do continuous forecasting, to not leverage that.
Can you dive a little more into what you mean when you say continuous forecasting?
No.
Maybe with some examples.
Yeah. So I think we did talk about this a little bit last time. We're gonna have to do some fancy editing on the last video, but we got into it a little bit, and that is when we talk about continuous forecasting. It's whenever we get new information, it should at least be a trigger or a question about whether we rerun the model, and that new information could be things like, oh hey, we got some stories done. Our throughput has changed. We got more throughput data. Well, let's take that newest, latest throughput data, let's incorporate it into our model. Let's run the simulation and see what happens. You're probably getting new data. Are you pouring yourself some more? I see that's a second glass. I don't have to say. I'm almost out.
Yeah, you're talking about continuous forecasting. I need to.
Yeah, fair enough. Now I don't even know what I was talking about. So
when you trigger for conversation, trigger for rerunning the Monte Carlo simulation.
Yeah, you should at least consider it because chances are, if you're doing these agile methodologies, chances are you are getting new information every single day, and that new information comes in the form of, like I said, other stories getting done, throughput rate. It could come from the perspective of, like we said, new work has showed up. It could come from the perspective of we've split. We thought we had 100 items that we're working on, but now it looks like we have 120 items we're working on. Right? Any of that stuff could be new information that we should be feeding into our model and rerunning it, and rerun it immediately. The second we get it, right? Essentially continuously. Did you want to say some more about continuous forecasting?
Well, that's the good thing. The positive thing is, increasingly we're getting exposed to more and more continuous forecasting as consumers, as users of apps. We talked about the Google Maps example a couple of times ago. Even Amazon is doing it these days. They'll forecast it, and then if you check your order history a couple of days later, they've reforecast it. Right. I know we said on Saturday, but you know what? It's getting here today.
Yeah.
They'll do this continuous reforecasting. So your customers are getting used to it through other sources already.
Well, and all the COVID-19 stuff, right? As they
Yep.
do more testing, as they get more hospitalizations, God forbid, hopefully your loved ones are safe, but as we get that data, right? It would be silly to say, oh, we've done all this testing, but we're going to ignore all that. I mean, don't pull a Florida, right? And say we're just going to ignore that data. We're not going to treat it as true. But it would be silly that
in general sense, in general terms, just never pull a Florida.
Yeah.
Regardless of what that is, don't.
That's fair. That's a Florida. So by the way, curve fitting, split rate, arrival rate, those are all pulling a Florida, by the way.
Pulling a Florida.
Yeah.
Just don't pull a Florida.
Yeah. So yeah.
Except if you're trying to forecast hurricanes.
Yeah, and we should probably post a link. If we ever figure out how to put this stuff on YouTube and ever figure out how to post a link, there's a talk that Prateek and I developed around hurricane forecasting, and they have almost perfected the concept of continuous forecasting. Right? They're always getting new information, incorporating in the models, and updating their forecasts based on how hurricanes. Speaking of which, so it's 2020, and we've already got it's June 3rd, and there have already been 3 named storms this season. So it's going to be a very, very active forecasting season for us.
Which is interesting because they do actually a couple of levels of forecasting, which we will probably get into next time. When the National Hurricane Center tries to forecast, when NOAA tries to forecast, they do 2 levels of forecasting. They first forecast how many hurricanes, how many named storms, and how many severe storms there will be in the season. And then when they get down to each storm itself, they try to forecast regularly what the path of that storm will be.
Yep.
So they're definitely they have a lot of data, a lot of models, and they've definitely spent a good amount of time trying to figure out how to predict hurricanes.
And it should be noted that they're very good at it. I mean, yeah. I know a lot of people like to make fun of weather forecasting, but the hurricane forecasting that we have here is, in my humble opinion, exceptional. I mean, given the complexity, given the scale and complexity of the problem, that they're trying to solve, they just do a remarkable job, I think. And every year,
it's probably because it's not all done out of Florida.
And it's probably because they're not story splitting and they're not worrying about arrival.
they're not accounting for the hurricane to split.
Yeah. How many times has this hurricane split into 2 or more in the past? Yeah. That's actually a good blog post. All right. So is there anything else before? Because I do want to transition into what we're going to talk about next week. But is there anything else that we should mention, we should warn people about in terms of hey, watch out for this when you're doing Monte Carlo simulation? Watch out for this thing.
I think you had sort of summed it up earlier, and I'll just rephrase it.
Yeah.
That start with as simple a model as possible that gives you the best results. If that really, really simple model is not giving you the best results, find out the smallest thing you need to tweak to that model. You don't need to start with a complicated curve fitting, split rate plus arrival rate model. Let's start simple and watch the results and see how well we're doing before we go to the extreme stuff. In other words, be agile with your modeling.
Wait, go figure. What? You mean this stuff has applicability elsewhere in life?
Wait a minute, eat our own dog food?
The last thing you just said, I don't know how much time we should spend on it here or ever, but at some point, maybe we should talk about all the simulations you played around with different complexities, things like always sampling weekdays from weekdays and weekends from weekends, or always sampling Mondays from Mondays, and always sampling Tuesdays from Tuesdays, right? And you played around with all these different complexities.
We did Markov chain Monte Carlo.
Markov chain Monte Carlo.
5 different kinds of Markov chain Monte Carlo.
And what we found, and largely speaking, in the end, it usually didn't matter, right? The approach.
There were definitely some cases where it mattered, but for majority of the cases, it really didn't matter.
Yeah, and those cases were very, very. If I remember correctly, very, very, very specific, very, very, very unique.
Yeah. It was cases when teams were really batching stuff a lot, or cases where towards the end of a release, all you had left were weekdays. as opposed to.
So essentially, all the things you shouldn't be doing anyway, that's when modeling breaks. So go figure, right? So yeah, but I mean, I think 80-90% of the cases, the simplest model always won out. I shouldn't say always won out, but usually gave as good an answer with as little effort. So, okay, so let's transition. Given that everybody out there in TV land is all experts in Monte Carlo simulation, what to do and what not to do. There is kind of one more layer of complexity that we haven't considered that we maybe need to consider. And that is this idea of, and now that I've had too much whiskey, I don't know that I'm going to be able to say it concisely. Say that we're trying to forecast how many features that we can get out. So we're forecasting at a higher level, where features break down into stories or epics break down into stories or whatever. We're trying to forecast how many features we can get done or how many epics we can get done. And again, without naming any names, there are some tools out there that can help you with this. And they can say, oh, you just put in all these features, how many stories you think is associated with each feature, and we'll spit out kind of a confidence with your ability to get these features done. If I explain that properly, I don't know. So Prateek, can you, without getting too much into the answer, can you talk about what we're going to talk about next week? Why there are some nuances, some subtleties, or maybe some not so subtleties that you'll need to watch out for in that situation.
Yeah, just as we've been talking about Monte Carlo in general of for the past couple of these episodes, there are things that you want to do and there are things that you don't want to do. And this becomes even more important for teams that are actually delivering to their customers at the feature level. Because teams and products and organizations that most of them tend to deliver at the feature level rather than the story level. Forecasting features is much more of a hot item than forecasting stories. And there are the things that we really value at the story level, which is right-sizing stuff and limiting WIP on the story level. That's what creates something that's stable at the story level. We want to talk about those things at the feature level as well when we get into forecasting on the feature level as well.
Absolutely, yeah, and all the things we talked about in this one, like how splitting things up can affect prioritization decisions and just risk management in general, and what levers do we have to pull, in terms of affecting our confidence, in the model or our confidence in the forecast. So that's all for next time. Hopefully you will tune in. But as always, I like to give my friend and colleague Prateek the last word. What would you like to say to kind of bring this episode to a close?
Well, yeah, the primary point, I think, two primary points. One, don't assume prioritization, delay prioritization as much as you can, and two, don't add assumptions to things that are already built on assumptions, and don't have turtles that go all the way down.
Yeah, don't create complexity where it's not needed, right? Yeah.
And I did we haven't done this yet, and she has been there in every episode that we've done. But that's Nisha, and she's the third one on this webcast, podcast, whatever you want to call it, at all times. She's always here.
That's what most people look like when Prateek and I start talking.
Pretty much.
That's pretty much. But Nisha's definitely our muse. She's like, oh my God, shut up! I'm trying to.
Yeah. She's like, you're embarrassing me, Dad.
All right. So okay. So thank you for joining us for this week of Drunk Agile. Like I said, my name is Daniel Vacanti, and then for Prateek Singh as well. We'll see you in the next episode. Have a good week. Bye.
See you then.